Greetings Dr. Amirul and also Dr. Irina. I am Vishwa, the first presenter from Group 1. So we are presenting about residuals and biosolids. So these are our group members, 6 of us. Okay, first of all we look at what is residuals actually. Residuals are broad collection of materials that are generated through domestic, municipal and also industrial process or systems, which can be found in wastewater. Examples of biosolids are ash, pulp, paper residuals, water treatment residuals from water treatment facilities, landfill discharge from mining process, waste and lime mud from mining process too, and also wood waste which can be found from factories or wood factories, and food processing waste, so which abundantly can be found on the wastewaters. So summarized as residuals are actually the form of materials that can be found in various type of wastewater. So residuals are actually materials that can be found on river, lakes or sea or all water bodies or wastewater channels. So what are actually biosolids? So as we looked just now, biosolids are actually one of the part from residuals, one of the residuals that can be found. But biosolids are actually nutrient-rich organic fertilizer and soil conditioners produced from solids, food and also poop or feces removed in wastewater treatment. So when the wastewater is actually get treated in the wastewater facilities, and the food and also our poop or feces are removed from that particular wastewater before they are sent out for the sea, to the sea or to the river. So that particular food and also the feces that they removed from the wastewater is actually biosolids, because biosolids come from our feces, and the food we eat provide all of the critical nutrients that a crop are required to grow, which is difficult to come by any chemical fertilizer. So they are being as an alternate supply of nutrition to chemical fertilizer. So means that the biosolids are actually a great alternate of chemical fertilizers. The biosolids actually contains feces and also food product, which is very good for the plants because it has multiple of macronutrients which is essential for the plants to grow, compared to other chemical fertilizers which eventually will produce much more waste and also much more chemical waste, and which can damage the environment. So what are the difference between them actually? Biosolids are sludge that has been treated to ensure that it can be safely applied to land as a fertilizer or soil amendment, as though as residuals is a typical municipal and industrial residuals include biosolids, sludges and others. So biosolids are actually a part of residuals. Residuals contains all kind of materials and also sediments in it.
Hi, my name is Tan Wenxin and my metric number is 211579. Today I will explain about how residual waste is produced. So for the residual waste, it is a non-hazardous industrial waste and it includes the waste materials for solid, liquids or gas, and this is produced by the industrial or mining and also the agricultural operation. So for the next one, how is biosolids created? So for the biosolid, it is the product from the wastewater treatment process. During the process, the water is removed from the sludge, which is we call that dewatering process with centrifuges, vacuums, drying beds or presses. And then the material is stabilized using one or more treatments method to reduce the pathogen and odors. And to make the biosolids safe for beneficial use such as fertilizer or soil amendment, they are treated physically and chemically to produce a semi-solid nutrient-rich product. So next, what is the types of residual wastes? So there are different types. From this got the metal containing wastes such as boundary slag, grinding and shaving. So for the next one is residuals, which is a sludge from the treatment of public water supplies, lime stabilized pickle liquor, electroporating waste from the manufacture of lime and cement, and the last one is the waste that generated by coal burning plants and residual waste incinerator. For the types of biosolid, they are classified into two, which is class A and class B. For the class A is virtually free of pathogen, but class B still contains some pathogen, but less than untreated animal manures. For the class A, such as like cured compost and heat dry biosolid pellets fertilizer, it can be used at anywhere. For the class B, it must be managed at site with little public contact in accordance with regulation. For the product class A, it is like mineral-like products that have been highly treated, but it may still odorous and best seal and manage like class B biosolid. For class B, like for some countries, such as New England, New York, and Eastern Canadian provinces, it is required site permits for use of class B biosolids.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Abdul Rasid. My metric number is 211025. How can we manage residual waste? As we know, households also have the residual waste collected because material recycling residual waste is impractical. It is necessary that combined heat and power plant, it should be known that residual waste is collected at household properties. As a result, people are no longer required to walk with this waste to recycling station. There are little that we can do with the residual waste, which is reduce, reuse, recycle, and dispose of residual material as little of possible. The management of residual material is gradually evolving as it recognizes that landfilling this material is harmful to the environment and public. Next, biosolid. How can we treat biosolid to the nutrient? Biosolid are a byproduct of wastewater treatment. The liquid are separated from the solid during wastewater treatment. These solids are then physically and chemically treated to produce biosolid, a semi-solid nutrient-rich product. First step, screening and pumping. The incoming wastewater pass through screening equipment where objects such as rag, wood, fragment, plastic, and grease are removed. Next step, grit removal. It is heavy but fine material such as sand and gravel is removed from the wastewater. Next, primary settling. Floating debris such as grease is skimmed off the top and sand with the settled material to digest it. In this step, chemicals are also added to remove phosphorus. Number 4, aeration. The pollutant are consumed by microorganisms and transformed into cell tissue, water, and nitrogen. Next, which is secondary settling. Allow the treated wastewater to separate from the biology from the aeration tank at this step, yielding an effluent which is now over 90% treated. The biology is continuously pumped from the bottom of the clarifier and returned to the aeration tank in step 4. Next, filtration. By filtrating through 10 micron polyester media, the material captured on the surface of the disc. Filter is periodically backwashed and returned to the head of the plant for treatment. Number 7. To ensure the treated wastewater is virtually free of bacteria, ultraviolet disinfect is used after filtration step. The ultraviolet treatment process kills remaining bacteria to level within our discharge permit. Lastly, the treated wastewater pass through effluent outfall where it's joined the river. That's all from me.
Hi, my name is Sarah Yasmin. My matrix number is 212473. So the first one is supply nutrients. One of the foremost benefits of land application of biosolids is the additions of plant essential nutrients such as nitrogen, phosphorus, and potassium. So applying biosolids to cropland gives producers an opportunity to gain plant available nutrients, particularly nitrogen and phosphorus, at a relatively low cost. The next one is improved soil structure. When biosolids decompose, they form a substance that glues and binds the soil particles together to form blocks. The end product is stable soil with good physical properties. The soils with an improved structure have increased porosity, which enhance the water penetration and decreases bulk density. So all of these factors combine to give favorable soil depth. So the last one is benefit the community. Communities can get benefit from the land application of biosolids because it frees up much needed room in sanitary landfills. In rural Missouri, which is in America, landfill space is already inadequate for solid waste needs, and suitable new landfill sites are not easily available. The costs to the community and considerably less with land application of biosolids that with disposal methods such as landfilling or incineration. The land application also provides an opportunity for the farmers and the city to work together in cooperative venture that benefits both groups.
My name is Adina Zohaira binti Azrin and my mentoring number is 213393 and I will be presenting about the disadvantages of residuals and biosolids. So as Sarah presented the advantages, and now let's talk about the disadvantages. So research indicates that the major classes of contaminant in biosolid pose a minimal risk to humans, animals, and environmental health. This is often because contaminants do not appear in sufficiently high concentrations to cause harm or because they are not taken up by crops even when present in soil. Residual waste is highly diversified both in type and in its potential to harm public health and the environment when improperly managed. Some residual waste components such as food processing waste present relatively little risk. So the advantages of biosolids are, the first one is disease-causing organism. One health risk with the land application of biosolid is the potential exposure to pathogens. Organisms in this category include, but are not limited to, bacteria, protozoa, and viruses. Pathogens can be eliminated by treating biosolids prior to land application using one or more of the many available treatment technologies for control of pathogens and vectors. The second one is toxic chemicals. Most pollutants can be considered toxic or harmful at certain concentrations or doses such as high concentration have rarely been found in biosolids. Common food, as I mentioned earlier, common foods or products such as salt or aspirin are safe at normal levels but also toxic at certain high doses.
Good day to all. My name is Phoebe Ong Jiahui and my metric number is 211280. Next, we'll be going through the topic of case study which related to residuals and biosolids. So our first case study will be combination of water treatments, residuals and biosolids affects two range grasses. It is about the beneficial reuse of water treatment plant residual, which is called WTR, and biosolids via land co-application. So the result indicate that the WTR can reduce P availability, which is a phosphorus availability, to blue grama and western red grass, even when co-applied with biosolids, which provide plant available phosphorus. The applications of WTR to soils could decrease plant available phosphorus while having little effect on trace element availability. Consequently, the high application rates of WTR should be avoided due to its adverse effects on biosolids bond P and also possible soil phosphorus availability. The next case study will be on residual use and energy conservation at wastewater treatment plant. It is about the energy conservation is considered a worthwhile goal because it conserves natural resources. The reduction in energy use can also lead to increased ability to comply with air emissions regulations. The carbon dioxide is the greenhouse gases, which is released by all the wastewater treatments and biosolids management processes. Converting the biosolids to fuel achieves substantial benefits from waste before carbon dioxide is ultimately released. In addition, non-renewable energy sources are replaced by renewable energy from wastewater. Here we come to the conclusion part. So first point will be biosolid is sludge that has been treated, whereas the residuals are biosolids, sludge, and others. The residuals are produced through industrial activity, mining, and agricultural operation. The biosolids can be classified to Class A and Class B. Residuals and biosolids needs to be managed and handled in proper way. And lastly, the benefits of residuals and biosolids are supply nutrients, improve soil structure, and also benefit the community.